Hey guys, my name is Mike, and this is Math Tutoring with Mike. Hey, before we jump into our video, there are just a few things that I would like to review with you. The first thing is that I want to implore that at the end of this video, by the time that you reach the end of this video, I want to make sure that you understand the principles that we went over today in this video. So if you have to stop the video at any point in time, that you're confused, or if you have to rewind, I really want to suggest that you do that. The second thing is that after you've reached the end of this video, that you actually go back and try solving the example problems on your own. Doing this, I find, is very important with cementing the theories and cementing the understanding, that you actually understand what was reviewed. So, thirdly, chances are you came to this video with a specific problem that you had. If at the end of this video you realize that I have not addressed the specific problem that you are looking to solve, I invite you to leave me a comment or shoot me an email with your specific problem or specific question. And you have my word, I'll do my best to either preparing another video or reaching out to you personally how to solve that particular problem. Anyway guys, so on to our video. Today we're going to be talking about subtracting fractions. I released a video out about addition of fractions, and the one thing I want to say immediately is that adding fractions and subtracting are about the same. The only difference is that you have the signs to work with. So in adding fractions, you have the addition sign, and in subtraction, you have the minus signs. I guess it goes without saying, but I wanted to point that out because it kind of would solve both the adding and subtracting of fractions in the same way. And in the same way that I showed you for the addition of fractions, I want to point out that when subtracting fractions, we have two scenarios. The first scenario is where we have the same denominators. So in this instance, we have the same denominators of 8. And then in another scenario, scenario 2, maybe I shouldn't do it like that, I don't want to confuse you. But in a second scenario, we would have a different denominator. So in this instance, we have to figure out how to subtract two fractions with two denominators. We notice that this method is really straightforward, but this one we have to do something, and that's follow the method of finding what's called a lowest common multiple. But let's look more closely at subtracting fractions with the same denominators, shall we? So scenario 1, where you have the same denominators, we want to now subtract fractions with the same denominators. So let's say we had a situation where we had 5848, same denominators of 8. So what do we do in our next step is just simply use, since we had the same denominators, we're going to now use it as a common denominator here. And then what we do is we just simply bring down the 5. Let me use a different color pen so you'll see. We're actually bringing down the 5 here, bringing the 5 there, bringing the 4 there, and then bring down the minus sign. So in essence, what we have is the 5 minus the 4, and then the answer is 5 minus 4 is equal to 1 over 8. Really simple. Really simple. If you do a similar problem 4/5 minus 1/5, and you apply the same principle. Next line is you just bring down the denominators. In this instance would be 5. And then you would take the first numerator and bring it down. In this spot, take the second numerator, bring it down. And then you brought down a sign. Then it would be 4 minus 1. Then the answer would be 3/5. Very simple when we have same denominators that we're working with. Now, what happens when we have different denominators? Different denominators. So let's use an example. 5/6 minus 1/2. You see in this instance, the denominators here is 6 and 2. So we can't use the first method that we just did with the same denominators because the denominators are different. So now we have to use what's called a lowest common multiple. Okay, and what we do is when we find the lowest common multiple, we want to put it in this position right here, the lowest common multiple. So let's find the lowest common multiple of 6 and 2. So first of all, we have to list out all the multiples of 2, which is 2, 4, 6, 8. And multiples are just simply go hand in hand with your multiplication table. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16. This is what is called multiples. And then we look at the multiple of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. So forth, so on. So the next thing you want to do is we want to find what's called common multiples. And let's now circle it. Common multiples in this instance between for the 2 and 6 values would be 6, would be 12, would be 18, and I'm pretty sure it would have been 24 as well. So let's just list it out. 6, 12, 18, 24, and the list goes on. But in this instance, we only care about the least common multiple. The least common multiple in this instance would be the 6. So now since we found the least common multiple, we now want to take that 6 and use it as our new denominator. So now that we found that, our next step now we have to convert the two fractions that we are working with. We now have to convert it to the new fractions with this lowest common multiple, and I'll show you exactly what I mean. So two fractions, fractions 1 and fraction 2. Okay, fraction 1. Remember, it was 5/6. So what we do here is we first look at the denominator. And we're taking this 6 and using it as our lowest common multiple. And we're saying 6 times what number gives you 6? We find that 6 times 1 actually gives us 6. So then what do? We then take that number 1 and we then place it as our numerator. And then we ask the question, 5 times 1 equals 5. So now we then take this 5 that we just found as our answer. Maybe let's use a different color. I don't want to confuse you. Let's use the color yellow. We then take this 5 and we put it in this spot here, if that makes sense. Okay, so the number 5 would go right there. Number 5 would go right here. Okay, and then we want to bring down our sign. We then want to look at the second fraction that we're trying to work in our problem here. Trying to figure out 1/2, and then we just look at the denominator. Denominator in this case is a 2. Okay, when we ask the question, once again we bring the 6 here. We ask the question, 2 times what value gives us 6? 2 times 3 is equal to 6. So then once we found a 3, we then transfer it now to our numerator. And then we ask the question, 1 times 3 equals 3. So then the second value that we just found now, we would put it in our second spot right there. And so now that we have done that step, our next step would just simply be solving the problem. 5 minus 3 is equal to 2. 2 over 6 is our answer. Of course, we can simplify this to be 1/3, but I think that's going to be another problem or another video. But in essence, this is how you find, subtract fractions with different denominators. Since we have time, why don't we do one more? Just want to make sure that you understand, or I'll be doing enough examples for you to understand. Okay, so subtracting fractions with different denominators. So here we have 4/5. 4/5 minus, let's say, 2/4. Okay, so first thing we realize is that we have different denominators. We realize that the denominators are not different. Okay, so what do we need to do? We need to find what's called the lowest common multiple. Okay, and recall, we find that by listing each of our denominators, 5 and 4, and then we just simply list all the multiples of our denominators. So for the 5, it's 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, 5 times 6 is 30. I think that would probably be enough. Then we look at the 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16, 20, 24, 28. You may realize that I'm stopping in this instance at the 28 or the 30 for the 5. I don't necessarily have to stop there. You don't have to stop there. You can continue on. What that would just simply do is increase the probability of you finding more common multiples if you just continue listing on. So what we found here, all the common multiples, we want to list in green, circle in green. So we have 20. Looks like there's no more in our list, even though I think the 40, because 40 would work out to be both numbers, and we could circle 40 to be here. So common multiples would probably be 20, 40, and just from my experience, just knowing that it's probably going to be 60 as well. But for our example, let's just list what we have here. And so our lowest common multiple then would then be the lowest number of the common multiples. And so we just indicate that number here as the lowest common multiple. Next, what we want to do is we want to then separate the two fractions, but not separate them, but just identify what we're working with. So fraction 1, fraction 2, and then we say the first fraction that we're working with is 4/5. we look at the denominator, which in this instance is the 5, okay, and we set up our problem like so. I always want that to be lowest common multiple. 5 times what number equals 20? Well, 5 times 4 equals 20. So then what we do is we transfer the 4 to the numerator. And we say 4 times 4 equals 16. So then the 16 would then go this spot there, our first spot. We want to bring down a sign. And we want to solve our second problem, which in this instance would be 2 over 4. And we ask the question again. Four times what number gives us 20? 4 times 5 equals 20. So then we would transfer that 5 to our numerator, and then we would say 2 times 5 equals 10. So we would transfer that number in that spot here, and that would be a 10. Now you have the problem 16 minus 10 divided by 20. So for us, the first thing you want to do is you want to say 16 minus 10 is equal to 6 over 20. So this is our answer, and if we broke it down, we would find that it would be 3 over 10. Like I say, I think I want I would love to show you how to simplify, but I think it would be a good idea just to keep it as is now and just show you how to simplify in another video. So that's it, guys. Subtraction of our fractions with different denominators. So you've made it to the end of the video. Good deal. I really hope that you understood what was reviewed today. Like I said earlier on in the video, I really think it's a good idea that you go back and try to solve the example problems on your own. That way you can prove to yourself, and you can help be sure that you actually understand the problems. Well, until next time, with another tutoring session, another math tutoring session with Mike. See you guys.